Okay, this is our CS Flex 1030 class, and we're going to continue our discussion on data structures. We've talked about arrays. Now we're going to talk a little bit about a different kind of list. A linked list, if you remember, an array you had to have a huge chunk of memory because all of the items in the array were stacked right next to them in memory. Well, a linked list is non-contiguous. You can have tiny pieces of data stored in different locations all over your memory. Now, each of those items in your list are called nodes. So, for example, here I have a node, here I have a node, here I have another node. There's node. Oh, I even have animations for my nodes. That's a node, and that's a node. All right, they're called nodes. This particular node is storing a number called 10. This one's storing 16. This one's storing 21. Now, along with the item it's storing, it's also storing another piece of information of where the next item in the list is stored. So this 10 is also, this node, I should say, is storing 10 and the memory location of this node. Then if you go to that memory location, you'll find the next number and the memory location of the last node. And on the last node, you'll find the number it's storing and then just a null terminator saying there's no more items in this list. So there's our two pieces, the item of data to be stored and also the memory location of the next node in the list. Now, the nice thing is if you want to add information to your list, it's super easy to do. All you have to do is set the pointer of the new node to the following location and set a pointer of the previous node to the new node. So let's show you how that works. So suppose we want to add 42 to this list. I just create a new node and now I'm just going to switch my pointer. So this pointer is now pointing to the same location of this pointer. It's now pointing to that 21. And now all I have to do is change this pointer to point to my new information. And now I've got all of my information stored in memory. Okay, now removing nodes is the same way. All you have to do is just change the pointer. If I want to remove this 16, I can just change this memory location so it points to this end node and all of a sudden that's now gone. So it's super easy to add nodes. It's super easy to remove nodes, to delete nodes, I should say. Okay, here is your turn. You're going to use linked list technology to solve this riddle. You're going to start with A. A is the first word in our list, and it's going to have a pointer that points to the next memory location. Okay, now here is the riddle. You have a boy, he was at a carnival, and he went to the booth where the man said, "If I write your exact weight on this piece of paper, then you have to give me $50. But if I can't write your exact weight on this piece of paper, I will pay you $50. And the man looked around and he saw no scales, so the boy looked around, didn't see a scale, so he agrees. He thinks, no matter what this carny writes, I'll just say I weigh either more or I'll weigh less. And in the end, the boy ended up paying the man $50. How did the man win the bet? Pause the video for a sec, kind of watch this, see if you can figure out the answer to this riddle by using linked list nodes. So in this case, we're starting at A, and remember this node is going to contain the data, the first word of the clue, and then a pointer to the next item in the list, I should say. Just pause the video. Actually, stop the video because the next one's going to start on the next video anyway. So, yeah, we'll see you in the next video.